You know, when an algebraic expression starts to get really complicated looking, quite often we can simplify it and make it into an equivalent but yet simpler object that we can then manipulate. So when you think about an algebraic expression, there are lots of pieces to it. And of course there's the variable, there's the thing that we don't know, that number that's hidden from us. And then any multiple, any factor in front of it, any product that we have with this, is called the coefficient. This is a constant, 5. So 5 times x, x here is the variable, and 5 is the coefficient. And when you want to try to simplify things, what we want to do is we want to try to combine like terms. And how do we determine like terms? We look at the variables and put together the similar variable. So for example, when you think of this, there's lots of ways of thinking about 5x. You could think of it as 5 times x, or you could think about it as saying that we have 5 x's. Either way is correct, but it turns out when we're trying to combine like terms, it turns out that it will be convenient to be able to figure out that this is actually 5 x's. So let's just take a look at a whole bunch of terms and see if we can identify the like terms. Let's forget about combining them. Let's just first identify them. Look at all this. This is just a long list of terms, and let's see if we can find the terms that seem alike. Well, when you look at this, it's sort of, wow, it's a little bit intimidating, right? Because there's also squares. This is 3x squared. This is 8y. This is just a alone. This is 4/5 y. X squared, 3x, y squared over 5, 4a squared. We have a negative x, and we have a negative 7a squared. Now, which are the like terms? Okay, well, when you look at this, you might first think, here's a great thing to think about, which is wrong. I see a 3 and a 3. Well, those are the same coefficients, but these are not like terms, because these are x squareds, and these are x's. So we're looking for x's. We don't necessarily care about the coefficient, or we're looking for x squareds. But these, the coefficients being equal, do not mean that these are like terms. So we have to look at the variables. So here I see x squareds. I have 3 x squareds. So these are x squareds. Are there any other x squareds run around? Well, there's an x squared right here, and that's it. These are just x's. They're not x squareds. And these are squares, but they're not x squareds. They're a squareds. So it's almost like a puzzle. You want to find the exact same shape. Well, here I see x squared. Here I see x squared. These are the same thing. So let's mark them. I'll write them with a diamond-y shape. These are like terms. These are like terms. Okay, are there any other terms that are alike? Well, let's just take a look at the next thing here. Here I see an 8y. Do I see, so this, I read this as, you know what? We've got 8 y's. So I'm looking for y's. Are there any other y's? Well, here I have 4/5 y. So that's y's. There are y's there. It looks like there are y's here, but these are actually y squareds. So that's not good enough. We're just looking for y's, and I don't see any other y's anywhere else. So these are y's. I'm going to use a green circle to show these guys are alike. What about a? A, all by itself, a. No, those are x's. These are y squareds. Oh, no, these are a squareds, and I'm just looking for a's by themselves, x, and these are a squareds. So no. So in fact, there is no other term that's like a. A is on its own. What about this 3x term? Do I see any terms that just have x's in it? Well, these have y squareds. These have a squareds. This is a negative x, so that's x, and this is an a squared. So I see, and I'm going to use the purple and make a squiggly purple box to show these are actually like terms. What about the y squared over 5? These are all squareds, but they're not y's, so that's off on its own. And what about the 4a squared? Well, I have a negative 7a squared. Those are a squareds. 4a squareds, negative 7a squareds, they're both a squareds. So in fact, they get a fancy underline because they are also like terms. So you see how you identify like terms. We don't look at the coefficients. We look at the variables themselves and make sure they're appearing to the exact same powers, like x squareds and x squareds, or x's and x's, and so forth. Like terms.